Okay, so now to kind of elaborate on the differences here, let's talk about Keynes both in the short run and the long run. Because remember, what these post-Keynesians wanted to do was take Keynes' short run theory and then apply that to the long run. Apply that to a system where growth is determined by demand. Okay, so let's be clear about what I mean. So first, let's talk about what Keynes' short run theory was. Okay, so I'll give you a very simple idea here. So in brief, there are two parts to this model. One is that investment injects money into the economy. Okay, so when I invest, I create a whole bunch of income. Okay, that is, when I invest, I'm spending some money which someone receives as income. And this injects this money, this spending power into the economy. Then individuals save a fraction s of their income and consume fraction 1 minus s. Okay, so I'm saving some constant fraction, say 10%, and then the remaining amount, 90%, I consume. Okay, so let's kind of see how this actually works. So imagine, as I said, that the savings rate, little s, is 0.1 or 10%, meaning people save 10% of their income. Okay, and now imagine $100 is injected into the economy through investment. Okay, so some firm invests $100. Well, here's what happens. So that becomes someone's income, right? Every time I spend, it becomes someone's income. So let's say this becomes person one's income. This is the person who, say, created the capital goods used by the firm. Okay? Person one saves 10% of what they receive, so $10, and they consume the remaining 90%. And when they consume that remaining 90%, so $90, that $90 then becomes someone else's income, right? They're purchasing, when they consume, they're purchasing goods and services from someone else, okay, from person two. Person two receives that $90 in income, saves 10% or $9, and consumes the remaining 81%. Okay, and again, they're buying from someone else, so that becomes someone else's income. Okay, that person receives that $81, this is person three, they consume 90%, they save 10%, and so on, right? This keeps going, etc. Okay, and so output then in this model is determined by the sum of all of these different expenditures. Okay, so the initial investment expenditure plus the consumption of person one, plus the consumption of person two, plus the consumption of person three, and so on and so on and so on. Okay, so in our model we have 100 plus 90 plus 81 plus 72.9, and it goes on. Okay, now obviously we don't want to work out, we're not going to sit here and, write out what's person four, what's person five, what's person six. Now, luckily there's kind of an easy way around this, okay? So for a given savings rate and investment, what is output? Y. Or what is demand? Y. Okay? And to explain this to you, we're going to work through this very simple thought experiment. Here's what it is. Imagine we're all sitting in a circle, okay? And I give you, the first person in the circle, okay? You are the first person in the circle. I give you 100 marbles, okay? Now you're going to remove 10% of what you receive, put them in a bucket, and then pass the remaining 90% to the next person in the circle, okay? And then that next person does the same thing, okay? The next person then removes 10% of what you give them, puts that in a bucket, and then passes the remaining 90% on, and so on and so on. And we'll keep going until all of the marbles are in the bucket. Okay? So in the end, how many marbles are in the bucket? It's not a trick. Obviously, the same number that I put into the circle, 100, right? What we're doing is I'm introducing these 100 marbles, and they're going to keep going around the circle until there are none left. And when there are none left, it means that all of them have been put into the bucket. Okay, so what does this have to do with our theory here? Well, in our case, taking marbles out is equivalent to saving, right? In the very simple model I just showed you, when I save, money is being withdrawn from the circular flow of income. Okay? Alternatively, when I consume, and this is the equivalent of passing marbles along, my consumption becomes someone else's income, and it continues to flow through this circle, this circular flow of income. okay? So by this logic, the total amount of savings, once this income flows through the economy, a whole bunch, the total amount of savings will just be equal to the amount of investment that was initially injected in. Okay? So in other words, investment is going to be equal to the savings rate times the total amount of income we get. Okay? Y must be such that, income or demand must be such that, when I multiply it by the savings rate, it's equal to investment. Or put another way, income must be such that we save exactly as much as was injected into the circular flow of income through investment. And so we can easily just rearrange this, right? To get what demand is going to be in the long run. Or sorry, not in the long run. What demand will be after, income goes through the circular flow. So income is just going to be I divided by S, just by this logic. Here's what's important about this, okay? Output is going to be determined by demand for goods and services, okay? And demand is going to be determined by this equation, right? This gives us, in the end, how much investment and consumption we're going to get. Notice that we're not considering the ability to supply these goods and services, right? Output is totally demand determined. It's determined by how much people are spending on consumption and investment. And we're not thinking at all about, well, can we actually supply everything that's being demanded? And so why? Well, the assumption is that in general, the labor and capital are underemployed. Okay, there's some excess amount of labor and capital that I can always use to produce more. Here's what I mean, okay? In general, we're in an underemployment scenario. So what I mean by that is, here's my output line, okay? So imagine that YP is productive capacity. This is what we could potentially produce. And it's going to be determined by, kind of our usual production function, if you want, or a production function. So it's going to be determined by the total amount of labor there is to supply in the economy, total amount of capital, and the technology we have. Meanwhile, YAD, so aggregate demand, everything that's demanded, is determined by I and S in the way we saw before. Okay? So given I and S, we get some aggregate demand, and we're saying that in general it's going to be less than what we could possibly produce, less than productive capacity. And the final step here is then labor demand is just determined by how many workers are required to produce what is demanded in the goods market. Okay, so that's the short-run theory. So then remember, these post-Keynesians came along and they said, well, we want to extend this into a growth theory. And the extension is pretty simple when you think about it. So what makes an economy grow? Well, output's determined by demand, and so therefore, what makes output grow? Growth in demand, right? It's increases in demand that should lead an economy to grow. Ceteris paribus, or all else equal, increases in productive capacity, so i.e. our ability to produce stuff, will not increase output. Why? Well, imagine that suddenly just a whole bunch, suddenly our capital stock is doubled, for example. Or suddenly the amount of workers available to work is doubled. Okay? That doesn't necessarily increase demand for goods and services. And since it's demand for goods and services that is leading to output, output is just being produced in response to that demand, well, then there's no reason why increases in productive capacity should lead to increases in output. So, one more time, according to the post-Keynesians, what makes an economy grow is growth in demand. Okay, well, so now define hat above a variable as its growth rate. So for example, x hat is the growth rate of x. Well, then let's kind of apply this just simply here. So remember, we have that y is equal to I over s, right? Output is determined by demand, and demand is given by the right-hand side of this equation. Well, then the growth rate of y, This is just a simple thing. I'll actually apply this later in the lecture as well. Whenever you have a product or a quotient, the growth rate is just equal to, so in this case, because we have division, the growth rate of y is just going to be equal to the growth rate of I minus the growth rate of s. Okay? It's just an identity about growth rates. Now, in general, we're assuming that s is constant, and so there is no growth rate in s. So that means the growth rate in y is just equal to the growth rate of I. So what makes an economy grow according to the post-Keynesians? Well, growth in investment, okay? That's the way that demand has to grow, according to this simple theory. Demand will grow because investment grows.